Class, what's the first thing we're going to do? Factor it. Class, can we factor this? No. How about this one? What do you get? X plus 5? X minus 2. Raise your hand if you have that so far. Okay, that's step number 1. Step number 2. What does it say on the board? Can I cancel anything?
No.
I'm going to tell you guys a cheesy story, okay? This is the previous problem. My cheesy story is this. The question a lot of students are thinking is, can I cancel these 2's here? And here's my cheesy story, okay? This x and 2, x plus 2, they're in a relationship. They got a thing going on. They're like dating or married. So can you just break them up and just say, I'm going to steal you and cancel the 2's there? You can't do that. You only cancel if they're both x plus 2. So you can't sit there and cancel, like, the fancy word is that you can cancel factors by multiplication, but these are together. So it would have to be an x plus 2. So we can't cancel anything. That means that there is no, which one? None. No donut on the graph. Okay? Alright, what's next? What's next? Set the denominator not equal to 0. This helps me find the what? The vertical asymptotes. Class, when you solve for this, you get what? X is not equal to negative 5 and x is not equal to 2. I'm going to show you this visually on my graph. The student had a question, why do you put not equals? And I asked the student, what kind of sport do you play? The student said, I play volleyball. I said, tell me the rules about volleyball. I said, can you jump, can you touch the net? And the student said, no. That's kind of like what an asymptote is. It's a boundary line. You can't cross it. The ref will raise a flag or do something. Here's negative 5. I'll write that down if I forget. Negative 5 and 2. Negative 5 and 2. Okay? Okay, so we found the discontinuities. We need to find the horizontal asymptote. Class, put your finger on the top degree. Well, if you have to put something here, it's going to be x to the what power? 0. We learned that anything to the 0 power equals 1. That is the reason why you cannot write x to the first. So the top degree is? Top degree is 0. The bottom degree, okay, this one confused students. Now, this is in its factored form. Is this x to the first? No, because if you multiplied it out using FOIL or the box method, you would get x to the second power. This is quadratics in factored form, and this is just quadratics in standard form, so it's still a power of 2. Remember, I'm looking for the largest one, so I'm going to put 2. Class, what inequality can I put there? Y is less than 0. And if you look at your chart on your formula sheet, when you put a less than, you'll always have a horizontal asymptote at y equals 0. Let's mark that on my graph. Now, before I do the domain and range and the end behavior, I'm going to create a table of values. And what's nice about our table of values is we already have some good boundaries. Oh, should put another one right there. The negative 5 is a boundary, so the vertical asymptotes are our boundaries. Someone pick two numbers to the left. Class, what numbers? Negative 6. Negative 7. Pick good numbers. Pick numbers between negative 5 and 2. 1 and 0. Those are good numbers. Always pick 0. It's super easy. And then two numbers to the right. 3 and 4. Remember, pretend the x to the 0 power is not there, so I'm going to cross it off. Let's do 2 by hand, and then I'll show you how to use the technology or your calculators to compute this table of values a lot faster. Okay? Someone shout out one of the numbers on the x values. 4. Class, what's 4 plus 5? 4 minus 2. 9 times 2. So we need 1 divided by 18. I get 0.05. You need to pay special attention if it's positive or negative. That is super important. Someone shout out another number. Negative 7. Negative 7 plus 5. Negative 2. Negative 7 minus 2. Negative 9 times negative 2. 1 divided by 18. Oh, we just did that. The answer is 0.05. Okay? So that's how you would do that by hand. Now I'm going to show you guys on this calculator. A student asked me, can you do this on the text instrument like a TI X3 double, whatever it is? I haven't found that it works. So I'm going to press table, number 3. I'm going to type in my function. You can choose either of these. I'm going to use the original one so I don't make any mistakes, and to me I think it's easier to write. I'm going to do parentheses 1, close parentheses, divided by x squared plus 3x minus 10. And I'm going to press enter. This is asking me for a second function. Press enter. It's asking me where to start. I'm going to type in negative 7. It's asking me where to end. I'm going to type in 4. It's asking me how to count. I'm going to say by ones. There's all my answers. Negative 7.05. Negative 6.125. Negative 5 is an error, which means what? Undefined. U. I'm going to look for 0. Negative 0.1. 1, negative 16.6. 2 is undefined. This was for what day?
Yes, please. The 3rd.
You didn't tell the date for me.
I got you.
Alright, where were we? 3.125. Okay. Now I start thinking about money. Think of pennies. -7 and -6. Class, which one is bigger, 5 cents or 12 cents? Class, which one? So this one's going to be a little bit higher. This one's going to be lower. So let's just say there's 7. That's 5 cents. That's closer to $0. And 12 cents is a little bit more. What's also important is you know if it's positive, it's going to be above the blue line. And if it's negative, it's below. 0 and 1, notice these are negative. Class, is it going to be above or below? Below. So at 0, I got -10 cents. And -16 cents is further away from 0. I got 3 at 12 cents. And then 5 cents is lower or closer to 0. If you make your graph, they're going to be smooth curves. Notice the boundary lines of the asymptotes. Class, tell me, how many vertical asymptotes do we have? 2, right? 1, 2. It breaks it up into 3 graphs. 1, 2, 3. That's why I had to pick numbers to the left, in between, and to the right. The last things I need to do is just the domain. Class, going from left to right, what are numbers I cannot pick? What numbers? -5 and 2. This is just a fancy way of saying that I can pick all the numbers between -infinity to +infinity, but I can't pick -5. That's what the parenthesis means. And you can't pick 2. How about the range? -infinity to what? What number can I not pick? 0. So to color code this, on the range, I'm going from the horizontal asymptote to the domain. The number I can't pick is -5. And the purple, which is 2, right? And then the last one is the end behavior. Class, what's the key word for end behavior? As x approaches +infinity, as I go from left to right. The last part of my graph here. Is it going up? Is it going down? What number is it going on the y-axis? 0. And as I go towards the left, where's my graph going towards? Also 0. It's like a plane. It's landing at 0. So all of these characteristics of a rational function you will have to do. Factor it, figure out the asymptotes, removable holes, graph it, table of values, and then domain, range, and end behavior.